Hi there, I'm Graham Lewis and this is a quick video on counting n items in a line. Imagine we have 3 items. Let's say we name them A, B and C. How many ways can we arrange A, B and C? Well, to do this you need a logical way to actually list them. So let's fix the A and swap over B and C. I've now exhausted the possibilities with starting with an A, so I need to start with a different letter. So let's start with B. Then I could have AC. Keep starting with a B, I could have CA, and I've now exhausted starting with B. So I'll start with C, and I can have AB, and then C, B, and A. And now I've exhausted all the different possibilities, and there are 6 ways of arranging A, B, C in a line. So if you think about it, there's an easier way to get there. I've got 3 letters that I wish to arrange. The first one, there are 3 possibilities. Now when I choose the second one of my possibilities is gone. So I only have 2 possibilities. And finally, all 2 possibilities have gone, so I'm left with only 1 possibility. And that of course is 3 times 2 times 1, which is 6 ways, and another way of writing 3 times 2 times 1 is 3 factorial. Now, here we have A, B, C, D. And we can see that if we have A, B, C, D, and if we do a similar method to listing them all, this is what we get. And you can see there are 24 possibilities. Of course, a quicker way is to do our 4 factorial. And we get our 24 different ways to list A, B, C, D. But the reason I actually wrote A, B, C, D is because I want to ask the question, how many ways are there listing A, A, C, D? i.e., if I swapped the B for an A, how many ways can I now list AACD? Do you think it'll be more, the same, or less? So I'm going to now swap all the B's for A and we'll have a look. So now you can see I've swapped all of the B's for A's and let's count how many we've got. It's quite interesting because obviously if I consider the AACD, have I got any more AACDs anywhere? Yes, one there, so cross it out. Let's have a look at AADC. 1 there, cross it out. ACAD, 1 there, repeated it, cross it out. ACDA, cross that one out. ADAC, cross that one out. And ADCA, where am I? ADCA, and I think that was meant to be, let's just scroll up there. ADC, yes, that was meant to be an A there. I apologise. So this one actually is ADCA, and I'd made a little error. Apologies for that. So cross it out. Let's keep going. CAAD. Have I got another CAAD? Yes, it is. Cross it out. CADA. Cross it out. CDAA. Cross it out. And then DACA. Have I got another DACA? Yeah, cross it out. DAAC. Yeah, cross it out. And DCAA, yeah, cross it out. So let's count how many we've got in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 ways of arranging A, C, D. So this is how we can do that in a quicker way. If we imagine A, C, D are in fact all different, we know there are 4 factorial ways. But I've made 2 of the items the same. And obviously I've had to divide the 24 by 2 to get 12. And there I get my 12 ways. However, I want to consider this 2 in a bit more detail. Is it really a 2? So here I've extended the idea, and if you look at the original list of A, B, C, D, and if I change the B's to A's and the C's to A's, hopefully I've generated this list here, which is correct. So how many ways are there of generating AAAD? And let's have a look. So I've got AAAD here. Let's see how many I've got. I've got another one there, another one here, another one here, another one here, and another one here. So I've got quite a lot of them. In fact, you can see I've got quite a lot of repetition, and there are 6 AAADs. So in actual fact, if they were all different, I would have 4 factorial different ways, 24 different ways, which is what we got before. But now I've got repetition of 6 each time. So instead of dividing by 2, I actually divide by 6. And 24 divided by 6 is 6. No, it's not. 24 divided by 6 is in fact 4, of course. My apologies. So we've got 4 different ways of arranging, which makes complete sense when you think about it, because you've got A, D, and I can move the D into 4 different positions. That's a D, sorry. And there we go. There's our 4 ways listed. Much, much easier. So now let's consider this 6, because in our last example, we had 4 factorial over 2, giving us 12 ways when 2 of the items were the same. Well, if I write this 2 as a 2 factorial, it might make more sense. It's the same answer, 12 ways, but let's see if that works for this now. So I've got 4 different items, or imagine they're all different, there's 24 ways, but then 3 of the items are the same, so divided by 3 factorial, which is 6, giving us the correct answer of 4 items. Let's do an example. Okay, so here's an example. Imagine I've got A, B, B, C. So I've got 1, 2, 3, 4, 5, 6 items. How many different ways are there arranging those 6 items? So if they were all different, there'd be 6 factorial ways. But I have 3 A's, so I need to divide by 3 factorial, because there'll be less ways. But I also have 2 B's, so I also need to divide by 2 factorial. And we can simplify this and find the ways. Remember, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. So you can see the 3 times 2 times 1's cancel. The 2 times 1 cancel with a 4 to make a 2, and I end up with 6 times 5 times 2. So 60 different ways. And that's an example of how to do it. So thank you for watching. That was a quick video on how to count in a list. Also, this can be used to demonstrate and prove the formula n choose r equals n factorial over r factorial n minus r factorial. If that interests you, go to my video generating formula for n choose r in my playlist Pascal's Triangle and the Binomial. Thank you for watching.